Okay, welcome back, everyone. This is episode 2, and we're going to get started on the memory section. I teased this next level at the beginning of the previous episode, the circular dependency one. As you can see, it's sort of split down the middle between arithmetic and memory. So there's two sections here, and they're kind of interconnected in this weird way. So I decided instead of just pushing all the way through arithmetic, I'd change things up a little and go for memory. And maybe just jump between those. So the titles may seem a little disorganized, but I think that's just the most fun. So circular dependency. Maybe we'll get a little more Turing Complete footage this time because last time I solved it in a weirdly short amount of time. So all right, let's get started. In our education system, we traditionally teach by tricking students into doing the wrong thing and then teasing them. I'm not sure if it benefits students, but teachers love it. Okay. Create a circular dependency. This is a circuit where the input of a component relies on its own output. In a circular dependency situation, it is not possible to determine the output of a component because you would first need to determine the input, which relies on the output and so on, hence the circular. This state is normally not allowed in other levels, but in this level, the goal is to create it so you understand what it is before going forward. Okay. Make a circuit where the input of a component depends on its own output. It looks like there's a check button here. Okay. Where the input of a component depends on its own output. Sure, I mean, I could just take a knot here, I imagine, because there's only one connection and then just wrap it around. Okay. That did it. Create a circular dependency involving at least two components. Okay. So I assume I could just do another knot. That felt like a cop-out, I have to say. I don't know if there's some more insightful way to do that, but that was the easiest way, I thought. So, okay, that level's already done. I don't think we necessarily... You know what? No. That's something we should illustrate in Minecraft, because I think it's relevant. So let's see, we're dividing this by architecture, or not architecture, by section. So this technically isn't the arithmetic section. Let's just say, if we go back to the map here, we'll say we'll do a new section in Minecraft, a new color block for the playing field, when we hit a new, when we surpass a new horizontal section, this line here. So memory and arithmetic will technically fall in the same area. And I think it'll still be cobblestone. So, okay, let's make a circular dependency. Now, I did sort of promise that I'd do every level, and I think it is important to do that, you know? I think there are going to be some that don't apply, but I certainly won't back off if the scope is seemingly too large. I will give everything a good, honest try. Okay, this should be pretty simple. Let's just take black concrete. Let's go with the knot gates, which we decided on in Turing Complete just there. So we do want that centered. So, yeah, circular dependency. So we're gonna take this redstone. I did want to clarify something. You may have noticed that I don't use repeaters, or I really try not to. I don't think I've actually ever used a repeater yet. That's because of timing. I know torches also add a little delay in circuits, but I don't know, it just sort of messes with me because typically you can use them to redirect circuits or redirect power to point at some block where that otherwise wouldn't be possible. I'm trying to use target blocks to circumvent that, or just directing the redstone dust appropriately, like you see here. Yeah, I just feel that I would get into situations where I maybe put a repeater on, I don't know, like let's say like input 2 of this NAND, but not the first one, and that just introduces really weird timing issues. And timing really is quite an annoying thing. So, yeah, I just want to minimize that where possible. I'm sure that that's eventually going to be required. And you know what? We can actually really simplify this circular dependency here with a target block. I did say that I was allowed to use target blocks as as much use. Yes, okay, perfect. That's exactly what I expected it to do. So Minecraft does illustrate the issue with circular dependencies. I believe that's considered a short circuit, if I'm not mistaken, which is disappointing because I did a whole year of study on this, and I can't recall what a short circuit was. But okay, so let's just call that circular dependency. And that's not going to fit. And what I believe to be a short circuit, where if I remember right, it's where two different levels of power are being supplied to the same conductor, or what is it? Oh, gosh, in Arduino, it's like there's a... We'll figure it out later. But for now, circular dependency. And then I think just for the heck of it, we could do we could do an OR here and then add the one with two components to illustrate that that's possible too. Which seems very self-evident, but you know, it's always good to just do it anyway. I'm a bit of a completionist in that way. And you know, that's actually not as straightforward because we're gonna have to block that. Kind of ruins the circularness. Oh, that does too, doesn't it? Well, actually, we're already up there, so why not? Oh, right, because that inverts it, so that wouldn't be a circular dependency. I mean, it is involving two. You know, that is interesting. If we go back to that, it's two knots connected, but they start off. So that's the thing with that's the thing with these is they start off the NOT gates, but torches naturally start on, so they're doing something. I mean, yeah, I think I guess we'll just scrap that for now. Just off the top of my head, I can't really think of how to establish that super easily. I think this illustrates it the best for sure because see the torch is off and there's nothing interacting with it. All right, moving on because I'm sure this is not the most entertaining. Let's go to the level, the episode rather, is called memory. So I feel like I should move on to delayed lines. And that's actually really funny because I just talked about the fact that I didn't want to use repeaters. And I haven't even read this, but I'm already thinking it's a repeater. This level introduces the delay line component. It takes its input and outputs it one tick later. That's really good. So what exactly? Wire color? Now we're talking, huh? That's like some good jumper wire colors. Oh, okay, so we're given one component, delay line. So I'm obviously gonna make this look a little better. Oh boy, I'm a little burnt today if you can't tell. Let's just check on the stream really quickly, see how we're doing. Yeah, we're looking good. Cool. Back to Turing. Okay, so let's try it. Is this delay line? Yeah. I mean, am I missing something? So if your input. Oh, okay. I mean, but what? We have one component. This should be pretty straightforward. Doesn't that seem like 2 ticks? Yeah, I guess I'm just not really getting it. What is our option? Like add 2? Yeah, I guess so. I guess I'm not really understanding. Okay, so we start red, and then it's green. Okay, here we are. So our input is green, and did it say was it 1 tick? So I guess this is 2 ticks ahead. So boom, 2 ticks, and then the output is now green. So then we register another tick, so that means 2 ticks later it'll be green, and then we also register another one immediately following that. So it's there, and then that's all good and dandy. It just keeps going. Okay. So that is something we're gonna do because we can actually do that really well. So I guess I'll introduce the repeater. So let's just say, yeah, we have I think a button would work well, but let's just stick to the lever for now for the sake of consistency. So imagine that a repeater is our delay component. This is a configurable delay component. So just basic lesson here. A repeater can conduct, electricity. It does so with, there's 2 redstone torches built into what looks like a stone slab. It's like a quarter slab. And then you'll notice that there's this arrow here, which is sort of not sort of, it is pointing to where it's directing its current. And so it's powering the lamp. So it's facing the lamp. Something unique about torches or repeaters is you'll notice that if I power it, it's a little hard to tell. Okay, yeah, I forgot that's a characteristic of repeaters as well. The powering it on is instantaneous, so it'll reach its. Gosh, I am not illustrating this well because I was totally under the impression that repeaters were 1 tick regardless, but it seems like it's only when you disconnect power does that 1 tick rule come into play. So let's look at this again. No, okay, I'm not crazy. So by default, there's a 1 tick delay, and you can configure this. So now it's 2 ticks, 3 ticks, and a maximum of 4 tick delay. See, that's definitely visible. So we're just going to keep with the level, which was, I believe it was 2 ticks. So we actually don't need 2 repeaters. We could just do that and then set it to 2, to a delay of 2. And there's the level. So what was that level called? Delayed lines. Okay. Nice. Moving on. I didn't actually think we would be going this fast, but odd ticks. Okay. In a previous level, I almost said precious, you learned how we don't allow circular dependencies. Now you must learn the one exception. Interesting. The delay line is allowed to depend on its own input. That makes sense. This is because its input does not influence the rest of the circuit until the next tick. Square pins in the game never affect the output in the same tick. They therefore never cause circular dependencies. Square pins? Oh, gotcha. So there's a square input pin on the delay component. Square pins in the game never affect the output in the same tick. They therefore never. Okay, I guess that makes sense. Output off on the even ticks and on the odd ticks. Okay. So I guess this, okay, so this is asking us to make basically a clock. So I'm wondering if we can connect multiple lines here. I don't like how they do this. You see how terrible that looks? And this doesn't look great either. It's not even visible. It's under the component. They need to release an update where that's a little more visually pleasing and comprehensible, because I think that does affect how we play the game. It's hard to tell what that is. This is my first, theory of what needs to happen here, and I guess I should have expected that. Seems like you always need 2 of these. Yeah, okay. I mean, I get it. It's always off. Now, I'd never want to view the solution. That's something I just don't want to do. It's allowed to depend on its own input. Square pins in the game never affect the output in the same tick. Okay. I mean, is it a matter of just sort of building this up? So let's get a standard. Let's get something going. They're definitely implying that we need a circular dependency. I'm not getting why it's always off when I hit next. It's like I'm not even affecting, because this should be sort of like a repeater in a sense, where it just sort of continues. But this does nothing. I supply current and it's not outputting anything. Alt click to move. Oh, okay, yeah. So that doesn't make sense to me. Outputs this tick's input next tick. So I'm not crazy, sanity check. That actually... Well, that doesn't even help. Am I crazy? I'm supplying power directly to the output and it's not even working. What? Oh, it's when the... Okay. Okay. So the input is always off. So how do we... That's a short circuit, which is different from a circular dependency. So my understanding of short circuit is, see, this is supplying high or 5 volts, and this is supplying nothing. Awesome explanation for the viewers. In electronics, and myself, 2 components outputting different values on the same wire causes a short circuit. That's okay. That's what I thought. However, by disconnecting output pins from a wire, it is possible for multiple pins to share the same wire, called a bus. Importantly, at most, one component output should remain connected each tick, otherwise you risk a short circuit. Okay, I suppose we'll learn more about that later. So that doesn't, yeah, that doesn't really help. This... I mean, is this not making sense? I'm just not seeing it. Let's connect this to an always on. Oh, look at that. Okay. So... Yeah, I don't need a wire comment. How do I get rid of that? There we go. Nope, that doesn't actually... I don't want to add a comment. So I can change the input manually, but the input is set to always off. Connect to the output. It's all fun and games. I guess that's just not making sense to me. Oh, okay, wait. If I set it... Okay, hold on. Now let's run it while it's on. What? Why does it reset to red? Oh, because it's running through this sequence here. Makes no sense. So if I'm supplying, according to this game, it should be on now because I supplied current. It's the next tick. I just said we wouldn't use the solution, but I feel, I guess, a little tempted to do so because this just simply isn't making sense to me. Let's look at the level log one more time. We don't allow circular dependencies. Now you must learn the one exception. So I have to make a circular dependency here. It's simply required. The delay line is allowed to depend on its own input. This is because its input does not influence the rest of the circuit until the next tick. Square pins in the game never affect the output in the same tick. Here's what I got. And we got a short circuit. Okay. What happens if I click it? Does it just reveal it? No, good. Just for the sake of it, let's... I think we need the always on. How is that a short circuit? I get it, the output's off, the input's on, but how am I supposed to make a circular dependency? How did I do it before? Delayed lines. Look at that. Okay. Right when I supply... Yeah, okay, great. Right when I supply power, the delayed line is on. I do it somehow in the next level, that's not the case. Which is very inconsistent. The exception to this are the square pins that do not influence the output in the same tick. They can therefore not cause circular dependencies. on the even ticks. So be it. Did they take my X NOR? Oh, I was gonna solve the problem. Oh no, they took the X NOR. Yeah, you got. Oh, you. Would you. Oh, because you could have easily solved it. Well, at least I have that much of a brain. This just doesn't make sense to me. How is it gonna be on if the input is always off? How is it ever on? You could just connect these and... Guys, gosh, I just do not want to, I just do not want to view solution. I'd kick myself so hard. Well, they took my X NOR, but they can't take my X NOR. You know what, they can, because actually they can. How do you, what's the point of a delay if there's no input power? I think we're gonna show the solution. Did the game just crash? What are you guys seeing on stream? Yeah, I feel like it just crashed. Oh no, I'm sorry. It opens a video in the browser, which I'm not on. Okay, so a little bird tells me you don't need the input. That's what a little bird tells me. Can you flip these? Okay, well, you know what? We actually got something, so. Oh, right, so it's actually, yeah. Okay, I think I'm just gonna check out whatever they've got going on here for the solution, because this is unbelievable to me. Great. He's just nodding it? No way. Well, I hope you guys forgive me for that was the first level I had to look up because I just guess I couldn't get out of my head about the input being totally off. You cannot the input of off because then the output will be on. So now you have something and then inverts it. That's actually easier than I thought. Okay, well, you know what? Sometimes that happens. So okay, let me look at this again. So there's a repeater and a not. So we're gonna try this. We're gonna try this in Minecraft. Let's just get straight into it here. We'll give ourselves 5 blocks of room. Okay. So first off, we're gonna have our not torch. Okay. As such, and it's gonna be connected to 1 tick. Ah, okay, it's powering its own block. So we'll just do a little bit of this, a little bit of that magic. Yeah. So we effectively made a clock. And see, that burns out because it's just a little too fast. So 1 tick is a little too fast for Minecraft, it seems. So yeah. Just a little too fast. All right, so that torch is not having a fun time. Okay, so lesson learned, think outside of the box. I guess I could have sat on that for a little bit longer, but you know what? And I guess naturally we'll give it a lamp. Wow. Notice no input, which totally makes sense for a clock because, you know, I should have remembered that there's simply no input on a clock unless you're initiating it or ending it. So let's move on. We're getting through some levels though, which is nice. Bit inverter. We are experimenting with how backgrounds influence cognitive functions in Earthlings. You'll notice the background looks like a terrible carpet. When invert is on, I'll output the opposite of value. Otherwise, just output value as is. When invert is on, okay, so there's two arrays of possible inputs. When input is on, output the opposite of value. Otherwise, just output value as is. So value and invert. A bit inverter. Lord almighty. These are getting hard. I mean, this isn't like, these aren't just gates anymore. This is like stuff to think about. I'm also totally burnt today, so that definitely doesn't help. Excuses. I'm honestly forgetting the task. When invert is on, so when invert's on, output the opposite of value. So value can't affect invert. You need invert first. When invert is on, output the opposite of value. When invert is on, okay, output the opposite of value. Okay, makes sense. That should power the gate. So We need to block it somehow. Okay, so if we connected that, it's totally fine up to here. Okay. So what if we knotted that and? But I'm sure you kind of saw where I was going there. But you can't short circuit something. Okay, I guess you can, but not with the square one. Whoop-de-doo. When the inputs are different. They really stripped our XNOR. That makes no sense to me. This level is exactly the same as the XOR one you solved before. Remember, no matter what we tell you the goal of the level is, the real truth is in the truth table. Okay, let's go check out the XOR. I'm hoping copy works. Beautiful. They said it's the same, so let's see if they're being honest. Okay, so I've yeah, I guess they're right, but you know what? That was not the same solution because I actually had the XOR, so it was a little smaller. But I'm actually just gonna leave that there, just so I'm sure it'll keep the components there. Check it again. Yeah, it will. Excellent. Okay. Well, that's it for that part of the memory. I guess we need to move forward with arithmetic, which might be a little more fun. I don't know how much I learned from that. I have to be totally honest. So creating an XOR is the same as a bit inverter? Okay, it's just like a different perspective on the same truth table. But you're still just trying to achieve the truth table. Okay. I have to say I'm a little heartbroken that I revealed the solution for the other one. I just can't believe that. But we're not going to hold ourselves to too high of a standard. So we are just trying to learn. And that requires a lot of patience and grace with yourself. So Okay. Bit inverter, which is, I mean, I don't know if that's even conceptually a bit inverter. Odd ticks, delayed lines, circular dependency. Short circuits and whatnot, and visual, and just knowing when that occurs is gonna be a tough one. Just knowing when that's happening. Yeah, it's just my brain doesn't make the connection of two outputs. Okay, so it's just two outputs with different values that are connected to the same conductor. Okay, fine. But it doesn't make sense that one of the outputs is off, and therefore why would it affect it at all? I guess low technically is like is low, right? There's some current going on. There's some level of voltage, even though it's marginal. So that, I suppose, would cause a short circuit. But I would like to know a little bit more of the physics behind that, because that doesn't, yeah, I guess it's not making total sense to me. Let's move on to counting signals. Okay, so looks overwhelming, but, you know, I always like to say the wave is not as bad as it looks. That's not what I say. I always say the wave is never as bad as it looks. So the output component of this level is a binary counter where the first 3 pins correspond to 1, 2, and 4. Great. Use the binary counter to display the number of signals. Check this hint if you get stuck. The solution for this level is not very neat and requires more components. Okay, so I think this is really where the rubber meets the road, and it's lovely that it's today. So, a binary counter where the first 3 pins correspond to 1, 2, and 4. Okay, so let's verify whatever the heck they're saying. Nope, that looks like 1, 2, and 3. That's clearly not out. Yeah, clearly not outputting 4. Okay. 1, 2, and 4. What is this? Oh, I'm sorry. The output component. I didn't even see this. The output component of this level is a binary counter. So this is a binary counter where the first 3 pins correspond to 1, 2, and 4. What? Okay. That should be 1. So be it. That should be 1 as well. Short circuit. That's what I fear. That outputs 2. We need to connect both of these. It seems like they just sort of need an OR. Not neat. Yeah, I'm gonna make it neat. Now that should be 2. So let's just say, let's throw an AND on. Okay. And let's throw in a couple more. Gotcha. So does that make 2 now? No, because of short circuit. So that should be off. So when they're both, okay, that should be off. So that needs to be a XOR. Okay. And I'm assuming that's going to short circuit. Yeah, okay. So when there's both, So let's just say one or the other then. Oh, I'm sorry. Okay, yeah, that makes sense. I get it. Yeah, I don't want to look at the counter. Okay. What? It was just working. Just working, guys. So, just working. There we go. Back to 1. To that. So input 3 needs to output 1, so it needs to be connected to that, to the first input. Gosh, that is just... I mean, what happens if we invert it? Does... No. Yeah, that would just add, keep adding. I was like, can we hit negative values? Do a little subtraction, but it's purely a counter. It's an adder, I think. This works up to here. Because that needs to power that, but we get a short circuit. Short circuits are going to be a very frustrating part of this journey. They all need to be connected to one input each. That's what I'm seeing. Does that make sense? So let's try the OR here. Let's connect that to 1. 1 is just going to be quirky. Okay. Right. Makes sense. So when 1 and 3 are going, but not both. Another XOR. When it's 1 and 3, you know, I'm using essentially no triple adders or triple ands, and I'm guessing that does something. Like, I'm sure I could make these a lot more efficient. No, see, look at that. How far does this guy go? When 1 and 3. Does that need to output a 2? Yeah. So that needs to be an XOR. Then we throw an AND into said XOR. Gosh, that looks just god awful. We're back. So we did advance, right? So now when these two, it's when those two are going. Throw on another AND, I guess. Lots of ANDs in the building. So what does that need to be connected to? That's the question. That needs to be connected to the 2. And you have an XOR there, so you need another XOR. Yeah. Back to 1. Another XOR. It's like centralizing the input is how you avoid short circuits. And you know what? Maybe it's teaching me a little something about short circuits. How to deal with it, or just practice with dealing with it. Okay, new combo. Great. 1 and 4. One and 4. Needs to be connected to 2. There's the 2. So I'm just going to connect this temporarily. Okay, so how far did we get? What? What? Oh, okay. I was freaking out, but I put the wrong wire somewhere. There we are. Okay, so 1 and 4 need to go to 2. So what that means is there. There. Or not. 1 and 4 need to go to 2. Another XOR. Okay. All right. Is it just ands and XORs? Is that what is that like the trend I'm seeing? Okay, so that's another 2. So this, another XOR. Connected to 2. Okay, another and. What is that, connected to 2 as well? These numbers are a little offset, aren't they? That somehow worked because it's adding 3. We have another 2 here. Still on 1. That's to 2. I can't believe this is gonna, if it makes it to the end, I don't know if I can believe it. Oh. All 4. I mean, easy enough, right? That's 2 ands. You just connect them all. I mean, they sure were right about this being neat. I just can't imagine that this, I don't know, I just can't imagine that this is even close to the most efficient. It certainly is a solution to whatever truth table they gave me, though. Look at that. I mean, first off, I don't have a bit, I don't know, a count adder in Minecraft. So I like, do we build this? Like, do we really build this? I'm gonna quickly glance at the solution on, oh wow. Wow. So I'm looking at the solution right now, just for context. I'm looking at the solution right now that they have, and it's not even that bad. Yeah, I don't think we did that bad. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16? 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I used 17, sure. Yeah. I used one more gate than the solution had. So overall, I wouldn't say that's too bad. I think that was probably attributed to the first part. I think we should eventually do this. Gosh, dare I say, but we should make an adder first. So let's just say under construction. Um, okay. Right, so that's like really complicated that's a huge jump from what we're doing right now. Like an adder? 5, 11, 23. I think we give ourselves that. Ooh. I think we give ourselves 25 blocks for that solution when that comes. And look, our space is quite unlimited. It's a matter of organization and speed to get around, but that was something, guys. Yeah, let's keep going, I guess. Counting signals. See, what time are we at in the stream? We're at 57 minutes. Okay, I say we do one more level and then we call it. This is kind of like the grind phase, where it's not feeling as good at the beginning. It's not as concrete, but it's introduction to these advanced concepts that we need to just start to think about. Because it gets much more abstract than just these logic gates, of course. Infinitely more abstract, it seems, but ultimately it boils down to this logic. So let's keep going. I think we go to half adder because that is lower than double the number, and I think we should do this programmatically. Okay, we measure the universe with numbers, so your machine must learn to count. Fair. Not entirely true, but fair. Treat the inputs as 0 or 1, depending if they are off or on. Okay. And that is also another great way of representing off and on that I should have added to the signs at the beginning of the series. 0 and 1. Add them together in binary such that the result is either 0 or 1. As with normal addition, if the result cannot be described with one digit, set the carry to 1. Okay, that's a step. That much is established. Add them together in binary, such as their result is either 0 or 1. Okay. What? How is that a half adder? This seems weak. This does, like, a half adder was such a hyped concept, and I thought this was an XOR and an AND connected to two different outputs. This simply doesn't make sense. Like, I literally just did the truth table. Do I dare build this and call it a half adder? I know you guys can't see it when I look at the solution. Oh, they don't show the solution to this one, do they? Do they not? That's a little crazy. Okay. That just, do we build that? A full adder? Okay, you know what? I think we build the half adder. This is just, you know what? That's what works. This is what worked. Because we need a little Minecraft, right? That's our interpretation of a half adder with the truth table. So an XOR and an AND, that's what we need. So let's just grab our smallest AND. Okay. And an XOR. You know, we actually did create a better XOR. Because we just take, we made a really good XNOR, and then, I mean, I won't say really good, but we made an XNOR, and then we invert it. Or prevent inversion, not sure. And then where do you paste it from again? I actually had a reference. The top right is where you paste it. So, what was that? I cloned it from there. Paste on the top right. Or was it the bottom right? I think it was the bottom right. Yeah, it was the bottom right. So we'd paste it like there. That's where we paste it. I'm not confident enough to just do that, but we would paste it there. So that would be, let's just say 1, 2. No, let's just say 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 8. Let's give it 11 because we're building. So 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So let's see. Yeah, we had the XOR on the left. You know what? It's fine. Okay. That's really far ahead. I think we can do with a little less room than that. What you guys think? Yeah, no, I think we could do with a little more room. Just for context, I do work as a I do work in IT. I primarily do software development. So when I'm home, I'm a little burnt from logic in general. Just, well, specifically computer logic. Oh, this looks a little low. Yeah, look at that. Gross. What is that? We're gonna clone that a little higher. Now we gotta kind of nuke all this. Yeah, I think that's okay. And then the and, which is infinitely simpler. So anyway, yeah, I do work as a programmer. Practically speaking. So it's, yeah, it's a bit rough, but you know what? I really enjoy this. So, and I just, you know, who doesn't want an excuse to play Minecraft? I don't know a person. So if that's the XNOR, then that's the XOR. Okay, because we invert it. There's the AND. Nope, that is not the AND. No, it is. I'm sorry. Yeah, we just need to invert it. Excuse me. Yeah, looks great. Levers are on roughly the same plane. Great, great, great. Okay. Do a little wrapping just for the mental satisfaction. Okay. So here we are. Now we have two inputs. Okay. One of them is connected to, okay, let's say these are our inputs. So how do we split this? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. 2, 3, 4. There's the center, and then we'll split the differences there. There are our inputs. And lever, lever. Great. Okay. So, you know, that actually sort of lines up pretty nicely because we could just pull that straight over. Because each input is connected to a part of, oh, I guess we'll go down in there. Yeah. Right. Great. So that's functioning. Okay. As for the and, yeah, I think it's one input on each. Okay. So let's say this is connected to yeah, okay. So let's bring this down. Okay. Let's bring that forward. Let's get rid of that. A little cleanup. Let's bring this over. Can we go any lower? No. I mean, but who's to say we don't do this? Yeah, I guess because then we're touching this. I have to make this a little funky. Just gonna verify that that XOR still works. So then we can bring the dust over here and block it. Right. And I forgot we were using gray concrete to indicate blockers. And I think we should quickly update our small designs over here. Actually, did we add any blockers today? No, we didn't. Interesting. Surely there are more to be added, but yeah, okay, everything looks okay. There we are. Yeah, so then we'll bring this over here. Oh, but that just looks terrible. We're gonna have to drop this. I'm smelling a target block coming. Okay. You know what? No. Didn't need one. Is that still respecting that? No, it's not. Ah, terrible, ugly, horrible, disgusting. What's going on? I mean, to be fair, how did I actually expect to connect that? I think, yeah, I think we have to bring the and up. Because there is no way to respect the boundaries and connect that. I mean, sure there is, but nothing practical. It's connected. Now we need to connect this bottom one here. So, I mean, I could just slab this and slightly change the design of the, you know, because that's not really affecting the, no, I don't think so. Oh, but you know what? It's going to climb. So we need to block it. I think that's okay. Okay. Right. Pretty sure that works. So, I mean, that alone is the circuit, because I shouldn't even say circuit. The component, the IC. I don't know what you would call that, because it's not going in a circle. It's just input and output. That's not really a circuit, is it? I guess if it's, no, I don't think that's a circuit. A circuit's like when you connect a battery, which has positive and ground, to a load, and it's going through the battery. It's flowing through. This is going from one point to the other. I don't know what you would call that. With full transparency, I don't know what you'd call that. But I do know what we would call these outputs, because the game tells us. The sum and the carry. So we'll do, obviously car is not really indicative, so we're gonna do this like that, right? Just to help ourselves, gives ourselves a little break later on. So that's the sum. And then I think that's self-explanatory. Okay. I think that wraps our stream for now. We built the half adder. I don't think I'll quote that, because that's a genuine concept. It looks like there's no hyphen. There's our half adder. So we have the carry and the sum. Okay, so yeah, when there's both, then you have to carry a 1. I guess that makes sense. Then you carry the 1. Okay, I wish it explained the half adder a little more, but I'm sure I'll do a little research when we're done here, after, you know, I close out just now, and I'll be able to come back on the stream and just maybe talk about some clarity and clarify what this all means. So I honestly think we should replicate the truth table. Yeah, we definitely should. So what? That's 4 wide, and then yeah, okay. So here's the middle. I don't know. It's just far enough where I think it's on this level, and then it's all the way over here. Usually I'm pretty good at eyeballing that, but I think that's right. Nope, too far. And we need 4. So we need that carry. You know what, we could just clone this if something goes awry with our placement. Okay, so yeah, the classics, both on, one on, and then both, right? Okay, great. And then you have these states, and then your carry. So input 1, input 2, desired sum, I'm sorry. I guess we'll do sum and carry. Okay, so the sum is when, yeah, that would be 1. And then you can't add 2 1s together because this is a 2's system, so it has to carry the 1. So I understand that to some, I guess I don't get the half. It adds only half, but not both, is what I'm assuming. Glad we have a truth table though, and you know, I'm satisfied with that. I think, yeah, I'll have more clear answers on our next stream, and we will definitely get back to the counting signals. That's something to return to. I think that was just a behemoth, and yeah, we might dedicate an episode later to that and come back to that because I don't know if that's in the spirit of the stream though. I feel like the next episode I should just crank that out in Minecraft. That would be, gosh, can you imagine? That would be such a pain. Anyway, thank you guys for watching. Always appreciate your time. I hope you're enjoying the series. I hope you're learning something. I'm certainly learning something, although we might feel a little stunted right now because the concepts are just getting a little funky. Persistence is key, and making sure you're interested, you know, and it's something you like to do, and it's something that I hope to learn. I'm trying to learn low-level programming, and I just want to understand the computer at the most fundamental level. In the age of machine learning obsession, I want to learn the low level, and I want to get good at that because it's concrete, it makes sense. I do really like machine learning. I'm liking it more every day. At work, I'm tasked with learning specifically the inner workings, like the math. And that's good fun, but it gets abstract and it gets abstract fast. And this is always very grounding to come back to. Just good old concepts, stuff that's, you know, comprehensible. I guess not to all, it's not everyone's cup of tea, but I think it's mine in a way. So in any case, thank you again. Have a great night, and please enjoy.